Greetings to everyone. I am Pranav Shukla, a senior simulation A working at Engineering Technique. Our discussion today revolves around integrated modeling and the simulation. You might be wondering what MODesim stands for. Let's take a moment to watch a brief video that explains.
Experiencing your design is made possible through seamless concurrent engineering and simulation that begins at the earliest phase of product development, enabling you to deliver the right product at the right time. When products were simple, engineering was simple. However, the increasingly complex connected products of today require engineering teams to stay one step ahead by understanding and predicting product behavior as early as possible in the development process. CAD and CAE technologies have evolved. However, engineering practices and workflows have not kept pace. Most modeling and simulation functions today perform as specialized, siloed disciplines, with each using separate, often incompatible software tools. When a designer shares information, that information must be translated and reworked into simulation software. Rigid handovers to analysts slow down collaboration, disrupt innovation, and prevent companies from timely delivery of these more sophisticated products without additional resources. What if you could break down the walls between disciplines and free analysts and designers to innovate in harmony? Integrated modeling and simulation, or MODSIM, makes it possible. MODSIM is a lean approach to engineering that can revolutionize the productivity of engineers and product teams. Seamless engineering, using one model and starting at the earliest phase of product development, allows engineers to confidently deliver the right product at the right time. Using an integrated platform to support multidisciplinary collaboration, MODSIM makes it possible to virtually model complex shapes and simulate their performance and behavior. Embracing MODSIM allows you to experience all aspects of your design by predicting a product's behavior much earlier, removing the expense of physical prototyping. Explore more design alternatives, allowing you to optimize the design to best meet functional requirements and manufacturing constraints. Finally, accelerate collaborative innovation across dispersed teams who all work on the same data in real time. Discover how, by experiencing your product with integrated modeling and simulation, you can deliver better products faster.
So I hope this video is concise video and you this give you some glimpse of the clarity about what the motion is. Allow me to explain in simple terms. Initially, the CAD model is designed using the CAD software. It is then converted into a step file and imported into a CAE software for a pre-processing and demeshing. The analysis is conducted based on the requirement of the solver and the software. However, if there are any minor changes needed in the CAD model, the entire process need to be repeated, causing the frustration for the CA professionals. Thankfully, the SIMULIA 3D experience provides a seamless collaboration between the SolidWorks and the SIMULIA. When you make changes into the CAD model in the SolidWorks, those modifications are can be reflected into the model available in the SIMULIA 3D experience. And all you need to do is replace by the revision and the refresh, and you are ready to proceed with the analysis. So these are the following topics will be covered in today's agenda, and I will provide an explanation for each one individually. So now first one is the 3D experience work. So in rapidly advancing world where extraordinary advancement become the commonplace in a no time, how any company maintain a continuous spirit of a transformation year after year. The solution lies in the simulation-based innovation, design, and the manufacturing. At the Dassault system, we are at the forefront of driving the solutions for a current and the future trends, ranging from the 5G technology to electrification, urban and mobility, communications, smart factories, personalized health. Dassault system encompasses various brands. As you can see over here, different brands are available. Okay, so these brands are the SIMULIA, CATIA, the SolidWorks, Dalmia, Innovia, Geovia, BioVia. These brands offer fully integrated solution within a collaborative environment provided by the 3D Experience platform. Now, the objective of the 3D Experience work is to revolutionize the product innovation process for the SolidWorks customer. This accomplished by offering a comprehensive cloud-based, fully integrated solution within the collaborative environment of the 3D Experience platform. Within the 3D Experience work, all the different disciplines and the stakeholders involved in the process, including the design and engineering, then you can say the simulation, then manufacturing, governance, and marketing cells are brought together seamlessly from start to finish through using the 3D Experience platform. Today, our focus will be on discussing the seamless capability and the integration between the SolidWorks and the SIMULIA options, which are part of the 3D Experience Works portfolio. In this course of this presentation, I will deliver the significant advantage of the simulation within the framework of the 3D Experience platform. This includes the seamless integration, then designer-centric UI user interface, extensive capability, the cloud-based accessibility, scalability, and the collaborative environment. In a simple term, the integration between the CAD and the simulation is seamless. The user interface of the Simulia is designed to be a user-friendly. It offers the advanced simulation capabilities like the crash test, drop test, damage modeling, and many more. Additionally, Simulia support the multi-physics domains such as the fluid structure, thermal structure, and many more. Simulia also provides the cloud capability with the server located in the Europe and the US. This allows you to run the simulation continuously, day and night, without keeping your system on. I hope this is quite useful thing. You can monitor the progress of the simulation from your mobile device, regardless of your location. If you have a deadline, okay, for the deadline of the project and need to speed up the simulation process, you can utilize more computing cores on the cloud the by purchasing the credits and tokens. Furthermore, the collaboration made easy with the 3D Experience platform, minimizing any potential communication gap between the teams. Now, let's explore the simulation-driven design of the e-bike within the collaborative environment. We are living in the future in all aspects. Technology has improved our lives, whether that be a breakthrough in the medicines, renewable energy, or any sporting ideas to keep us active and live longer. One of these changes is an electric bike. Join us on the exciting and remarkable MODeling journey of e-bike. In order to illustrate the MODeling workflow, we will be using the e-bike known as the CityStar, which has been meticulously designed using the powerful tools offered by the 3D Experience platform. As you dwell into this presentation, you will get a glimpse of the future where owning a e-bike like this, the CityStar might become a reality as it serves an inspiration for the possibilities that lies ahead. Now, let's first understand what is the MODeling approach. As you know, the simulation gives the insight into the product information, product performance before it comes into the reality. It has brought a lots of advantage to the manufacturer, designers, and the supplier by saving the cost and the time. But that is not enough. We can go beyond it. We can save more cost and the time with other additional benefits if we collaborate effectively and efficiently. That's exactly where the more things comes into the play. 3D Experience platform brings the designer, simulation engineers, decision makers all together by providing a collaborative, unified environment. The whole MODeling approach can be classified into the five classes. We will go one by one. So in this class three, in this case of the of an e-bike, the requirement to be addressed by the manufacturer are lighter frame, lighter motor pack, the extended battery range, and compliance in terms of the crash and the electromagnetic compliance regulation. Now, the task force to facilitate the smooth communication and the collaboration among the stakeholders, we have integrated the collaboration tools dashboard, such as the dashboard and the project management features. These tools enables us to track a progress of the task and the share necessary data with the different stakeholders involved in the e-bike design process. For e-bike, the original equipment manufacturer OEMs engages with the suppliers of the electric motor and the battery for the discussion of the new requirements. To entire collaboration and the project management for the new design cycle takes place within the 3D Experience platform, ensuring the seamless communication and effective coordination between all the stakeholders. Now, the class one is the heart of the MODeling approach. That represents the tight integration between the modeling and the simulation. Let's move on to understand the MODeling journey of the e-bike where the concurrent design and simulation iterations are executed between the SOLIDWORKS and the 3D Experience platform to assess the structural durability, electromagnetic plastic injection molding, and the thermal performance of various subsystems of e-bike. Additionally, the compliance readiness of crash and electromagnetic interference is visually tested. So as you can see, the compliance, crash compliance, and electromagnetic compliance has been tested. The strength and durability has been tested of the frame. The motor performance has been checked, and the battery thermal management has been checked over here. And this one is the manufacturability of this casing of this battery has been also checked using the plastic injection molding. I will explain this thing now. This one is the roadmap or the step involved in the e-bike motion journey. Now let's start with the requirement. So the first one is the lighter frame. So when it comes to improving the bike performance, weight is the tangible. Durability and the reliability are the most important consideration, especially off-road bikes such as the mountain bikes. Lighter weight often coincide with the reduced durability. So it is important to ensure its strength and the durability for the better and the reliable user experience. The second thing, extended battery range. The range is a concern. Extending the battery range is possible. The most, or probably the most uh, important and single decisions for the designer due to its impact on the user convenience. Also, it is necessary to ensure riders' safety from thermal standpoint across all the riding conditions. The third one is a lighter, quieter, and the efficient model. So lighter, quieter, and efficient model is needed to maximize the torque and minimize the torque ripples for a smooth acceleration and reduce noise while achieving the targeted efficiency for a lighter models. Compliance. There are two types of compliance, crash and the electromagnetic. So in crash compliance, safety should always be first. So bikes should be safe enough in the crash performance. And in electromagnetic compliance, these days consumers are very technology oriented with devices such as the smartphones and tablets being a significant part of our daily routine life. Designers are being challenged to provide similar level of intelligence and the functionality within the modern e-bikes, either through a dedicated dash onboard device or by providing a connectivity to smartphone or tablet. Hence, it is essential for the e-bike to comply with the electromagnetic standards and the regulations. Now, moving ahead. So, in this way, the efficient requirement management, we can understand the key market drivers and compete as a market leader by addressing all these challenges smartly throughout the product innovation. Now let's talk about the how collaboration happens on the platform while executing the MODeling approach. So over here, throughout this process, you will see the handshake between the SolidWorks and the 3D experience platform simulation rule. You can say the simulation. Now moving further, these are the four rules on the SIMULIA 3D experience platform available. The first one, these four rules are going to use for the analysis purpose. The durability and the mechanics engineer will be validate the strength and durability of the frame. The plastic injection engineer rule evaluate the filling times and the checks the manufacturability of non-functional design for a casing. The electromagnetic engineer will assess the electromagnetic performance and emission from the entire bike, and the fluid dynamic engineer will assess the thermal behavior to ensure the efficient cooling of the battery. With this kind of collaboration on the 3D experience platform, we can easily break the silos with fully integrated multidisciplinary environment. So seamless interoperability between the SolidWorks and the 3D experience platform with the concurrent modeling and the simulation functionality, we can enhance the operational efficiency. Now, let's understand how the model-based digital transformation is a key part of the 3D experience platform. So we move from the SolidWorks desktop to the cloud as the first part of this transformation. It's nothing but the SolidWorks installation. We can do installation now from the cloud and we can open the SolidWorks from the 3D experience platform. As you can see over here, the 3D the collaborative designer of SolidWorks, where you can install from that and you can open the SolidWorks from the 3D experience platform itself. Now, the second part of the digital transformation is the digital continuity, in which the first step is to save the SolidWorks CAD geometry to the 3D Experience platform, and there is no import or export of the CAD data required. This step also ensures that once the geometry is uploaded to the 3D Experience platform, it can be accessed by team member from anywhere at any time on any machine where the SolidWorks and SIMULIA is installed. I'm repeating this thing. I'm repeating this thing. Once you made the CAD model in the SolidWorks SolidWorks using the 3D Experience platform, you save this data into the 3D Experience platform. Now, for example, your company is in Vadodara and your other branch is in Bangalore. So, if you are using this platform, then the other branch also utilize this thing if they also have installed the SolidWorks and the Simulia app over there. Same way, if you have your branch over the India and other branch in the Europe or the US, at the time also, if you save your data in your 3D space on the platform, the other branch of other country also can utilize this thing. So this is the amazing thing. I hope you like it. Once the file is uploaded, we'll open the geometry on the Simulia app and start the simulation setup process. Let's take a look how the digital continuity work in real. So let's take a look. First, you have to log in on the cloud dashboard, then click on the compass. Now search the SolidWorks app, click on the SolidWorks and open SolidWorks from here. Once SolidWorks has been input, now you open this geometry from here. Now you have to save this geometry in a 3D Experience platform. Once you save this thing, anyone can open from anywhere in the world. But you need to give the access to that particular person who is working with you in the team. After that, you can open the Simulia itself from the SolidWorks as well. As you can see, mechanical scenario has been opened. This is the structural mechanics role of the Simulia, and you can see over here the Simulia over here, Simulia mechanical scenario on the 3D Experience platform. So you can open this part in the Simulia, and after that you can perform your the pre-processing work and the post-processing work as well over here. Now moving ahead, so this is what we have seen on the desktop to cloud, the digital continuity. Now let's move ahead with the simulation-driven design. The first one, the first role which has been used for the analysis purpose is the durability and the mechanics role. This durability and mechanics role enables the comprehensive structural simulation covering the static, implicit, explicit dynamics, and the fatigue to assess the structural integrity of any product where the industry-leading Abacus solver has been used. So this is the video of it. I'm just start this video. Start this video. One second, I just because of the pointer, I'm not able to start. Yeah, so you can see over here how the durability mechanism has been used. So this one is open. The app has been opened, Simulia and durability, and the loading condition has been applied. And you can see over here, the one message trace, and uh, the life also extract using over here using the durability mechanics rule. You will find the where the life is less, and based on that, you can change your design, as you can see over here. So, I started with the SolidWorks desktop and connected to the 3D Experience platform. This gives me access of advanced structural simulation capability based on the proven Abacus technology. I set up the typical load cycles encountered in the city ride to get a maximum stress of the frame. The durability analysis identified the most critical connections of the frame, and I then able to dimension the bars properly to meet the frame requirement. Now moving ahead with the second role which has been used in this motion journey of the e-bike, which is the electromagnetic role. So in electromagnetic role provides high performance 3D electromagnetic simulation for designing, analyzing, and optimizing electromagnetic components and the system on 3D Experience Cloud. The the user values of this can be listed as the industry leading solver, which is known as the CSC solver. Hope you might heard this solver. Whoever in the electromagnetic area, they might definitely heard this CSC solver. The solver is the base solver, and with this solver choice are broad range of the application and easy to use built in workflow for the electric machines. Let's take a look, a short video on this. The motor is used in e-bike is the permanent magnet synchronized machine, PMSM, the performance of which cloud be validated with EMC. In this case, the engineer is aiming to increase the torque while reducing the amplitude of the torque ripple for targeted efficiency and the motor weight. Now moving ahead with the third one role which has been used for this e-bike journey, which is the fluid dynamic engineer. This fluid dynamic engineer role provides designer and the simulation engineer with insight into the flow and thermal performance of the battery, which are critical for their optimum functionality. The values delivered to user from these roles are such as the designer-centric user-guided interface, automated meshing with the boundary layers, RANs, solvers, which is different turbulent models are there, and the comprehensive flow and the thermal physics. Let's take a look on this. Okay. So our battery supplier has made a significant redesign the of the pack using the SolidWorks. This have added an additional battery module consisting of the 10 cells, resulting in the 4 module pack. This modification expected to increase the theoretical range of the battery by the 33%. During the redesign process, a concern was raised regarding the operating temperature of the battery to ensure the safety. To address this concern, the supplier connected SolidWorks to the 3D Experience platform. By doing so, they are able to take advantage of the thermal simulation capabilities available on the platform. The connected simulation to assess the battery cell and casing temperature under maximum operating torque condition. Now the last tool which has been used is the plastic injection uh, engineer. Plastic injection engineer. This rule will help the battery casing manufacturability in terms of the plastic injection molding process. First one is the designer-centric user-guided interface. It has the automated modeling and meshing capability is there. Extensive plastic material library is there. You can check the filling, packaging, cooling, and injection process evaluation is in this role. And you can also check the warpage analysis with the Abacus solve. Let's take a short video on this. As you can see, the left one take the least time in the filling. So the battery, just explain this thing. The battery supply took advantage of the injection molding simulation capability on the 3D Experience platform to evaluate the uniformity of the plastic flow in both the version of the molds. The casing with the open slots show a longer plastic filling time because of this and the additional cost of the mold for the casing with the open slot, the supplier choose the second one. The supplier choose to go with the initial close casing design. Now, in this structural mechanics rule used for the strength. In structural mechanics rule, you can check the structural strength of the design. Here, the crash analysis of the e-bike has been performed to check its behavior during the crash and effect on the frame. This structural mechanics engineer role has industry-leading Abacus solver, Abacus explicit dynamic analysis you can perform. The comprehensive material models are available. The robust contact modeling is there. So let's look a short video on this. Now I now hope you have a look at this the crash simulation. You can have an idea how the frame will behave or the other parts behave during the crash. Okay. So this analysis has been performed using the explicit dynamics Abacus solver. If you would like to perform the crash, impact test, drop test, bird strike with the SPH method, this explicit dynamic solver is absolutely fulfill your requirement with having the additional benefits of the cloud computing. Now, the electromagnetic role. The electromagnetic role offers the powerful 3D electromagnetic simulation on the 3D Experience Cloud. With the industry-leading CST solver, it enables design, analysis, optimization of the electromagnetic components and the system. This role provides a capability for evaluating the structural signal integrity, power integrity, and EMC electromagnetic compatibility, and includes sensor and the antenna simulation with a comprehensive antenna library. Now, let's look on the emission, electromagnetic emission in this bike because of this the tablet or the mobile phone device is placed either on board or the connection has been given. So this is the emission radiation you can see due to these electromagnetic radiations. Now, to the rigorous electromagnetic wave emission simulation, we have thoroughly evaluated the emissions from our new model, including the wire that connects to the handlebar and acts as an antenna. We are pleased to report that the results demonstrated emissions well below the compliance level required for the certifications. This achievement ensures that our new bike meets the necessary standards and can successfully pass this certifications process. We remain committed to delivering the products that prioritize both the performance and the compliance. Now, what we have checked till now, the lighter frame, then extended battery range, lighter, quieter, and the efficient motor and the compliance in terms of the crash and in terms of the electric motor. So our product has undergone the rigorous assessment in the key areas. We have ensured the durability of the frame, optimize the thermal performance of the battery, enhance the motor efficiency using the EMC analysis, achieve compliance with the electromagnetic emission standards, and prioritize the crash behavior for a user safety. This efforts reflects our commitment to delivering a high quality, efficient, and safe product. Let's take.
Hi, this is Steven from Heiko. Let me introduce you to our latest electric bike, the City Shark. To develop this model, we listened to our customers' feedback, expressing the need for a lighter city bike with an extended range. Our product management team first targeted a lighter electric motor, since it's the heaviest component on the bike. The requirements were sent to our motor supplier. Then, we asked our battery supplier to develop a battery pack that would extend the range by at least 25%. At Heiko, we're now adopting the MODSIM approach when developing our new products. MODSIM is the integration of modeling and simulation throughout the product development cycle. The 3DEXPERIENCE platform allows us to easily create different variants of parts and associate specific simulations to these parts to do design exploration. We can then select the best part that meets our requirements. The 3DEXPERIENCE platform contains all the tools that we need to define requirements, do project planning, and communicate with all the people involved in the project. MODSIM clearly reduced our development time and prototyping costs. On our side, we aim for weight reduction by designing the frame with smaller bars than on our previous models. Heiko is now using 3DEXPERIENCE Works, so I started from SOLIDWORKS desktop and connected to the 3DEXPERIENCE platform. This gives me access to advanced structural simulation capabilities based on proven Abacus technology. I set up the typical load cycle encountered within a city ride to get the maximum stresses on the frame. The durability analysis identified the most critical connection to the frame. I was then able to dimension the bars properly to meet the frame requirements. At the same time, our motor supplier took our requirements and started designing a new version of their motor. They started with redesigning an existing motor in SOLIDWORKS desktop and leveraged 3DEXPERIENCE platform to validate the electromagnetic performance of the updated version. They modeled multiple configurations of coils, magnets, and core materials to compute the torque against angular velocity curve. With a simulation-driven design approach called MODSIM, they came up with a motor which is smaller and lighter, with only a small loss in maximum torque. Our battery supplier proposed an extended version of an existing battery pack. They redesigned the pack in SOLIDWORKS to include an additional battery module composed of 10 cells, leading to a 4-module pack with a theoretical increase in range of 33%. A concern regarding the operating temperature was raised to ensure safety. By connecting SOLIDWORKS to the 3DEXPERIENCE platform, they were able to leverage thermal simulation capabilities to assess the battery cell and casing temperatures at maximum torque operation. Then, they updated the casing design with open slots and concurrently updated the thermal simulation model with minimal effort. In the end, the maximum cell and casing temperatures between both designs were not very different. They also took advantage of the injection molding simulation capability on the 3DEXPERIENCE platform to evaluate the uniformity of plastic flow in both versions of the molds. The casing with open slots showed longer plastic filling time around the slots. Because of this, and the additional cost of the mold for a casing with open slots, the supplier chose to go with the initial fully closed casing design. All of our suppliers rapidly shared their revised designs within the collaborative environment of the 3DEXPERIENCE platform. I was able to access all the new designs and quickly build a complete digital twin of our new e-bike. I then did a crash test simulation of the bike against a wall to identify weaknesses in the assembly. The visualization of the crash really helps to understand what would happen during such an event. Manufacturers are also responsible for the electromagnetic emission compliance of their products. Therefore, we simulated the electromagnetic wave emissions from the new motor. I was even able to include the wire that connects the controller on the handlebar to the motor, which is acting as an antenna. I was able to see that the emissions from our new bike are below the compliance threshold and that it can pass certification. Now that we leverage the 3DEXPERIENCE Works portfolio in our regular development cycle, we can easily develop a true digital twin that can be fully tested and certified even before building the first prototype. With the MODSIM approach offered by the 3DEXPERIENCE platform on the cloud, we enhanced our product performance in terms of strength, durability, manufacturability, thermal and electromagnetic efficiency. This helped to minimize prototyping costs, enhance product quality, and accelerate time to market.
Okay. Sorry for the video voice is not available, but yeah, I hope you got the brief overview of today's all the topics which has been covered. So it is the purpose to show the the what kind of roles are available on 3D Experience platform, which can be useful to you in your company or your company's growth. So now moving ahead with the 3D Experience work, the takeaways in terms of the engineering. So 3D Experience Works provide the perfect environment for the SOLIDWORKS user to innovate with the MODSIM approach. In this way, the digital continuity from the requirements to delivery, simulation-driven design, exploration, the tight integration between the multiple discipline, seamless collaboration across the supply chain, high performance cloud computing you can perform. And in terms of the business standpoint in MODSIM approach is fast time to market, innovative product portfolio, reduce prototyping, compliance and warranty cost, enhance the operational efficiency, and reduce the IT infrastructure or IT cost. Now, this one is the SolidWorks. Sorry, this one is the SIMULIA Works structured product matrix, and there are the different roles are available. Structural designer is the first beginner role, then structural engineer is there. These both roles are at the linear level, and they have this some capability mentioned over here. And the performance is for the non-linear thing, which also has the capability of the structural design and engineer role included in the structural performance. And this structural mechanics role, it is the top one of the top role, and it has you can see over here the non-linear dynamic, explicit dynamic thing is there, the parasitic is there, and you can have the material calibration app. In the material calibration app, like you can import the test data, and based on that, you can choose the number of material models and which material model is near to your test data. You can extract that thing also using this material calibration app, which gives you a more realistic results. So please take a one screenshot of this Similia Works structured product metrics. So it helps in our future communication. Same way, I hope you take this screenshot of this thing. And also we have the this role of the computational fluid dynamics, which is known as the fluid dynamics engineer role on the Simulia 3D Experience platform. Please take this screenshot of this one. So if you have the requirement regarding the flow CFD, and at that point we can talk on this thing as per your requirement. So, this is from my side. I hope you guys found this MODSIM approach useful. If yes, then you can also type Y in the chat so we can have some you can say the feedback. And if you have any questions, that also you can write into the chat box. I'll try my best to answer it now, and if not, then we will connect later on. If you are planning to buy the FE or CFD software, then please contact the sales and marketing team to arrange the one-to-one meeting. So if you have any question or anything, please you can put over here.